Hit USB hub.
Hello guys, it's me Malachi K's here.
Hello gaze, the scare spirit.
Okay.
No, it's the erected Rowan.
There two past what I said, and it looks like most of you have completed because I see posters on the board. So now I would like all your attention so we can go over this a little bit and we'll be done and you can work on your homework.
No.
Okay? So
Why do you know
Open.
let's make some comparisons here.
Because I just do it.
Okay, Malachi, Rowan, William, please. Okay, touch it up here. Just give me 5-10 minutes and you guys can go back to whatever you're doing. So as we look at these, okay, first of all, are they all U-shapes pointing either up or down? That's good.
They're U's.
Right? They better be, or there's a mistake. Are they symmetrical U's? In other words, do we all have a line of symmetry going right down the middle? We should, right? Now, the artistry depends on who's doing it sometimes. Some of these look pretty good. Some of them look like they're a little goofy, but that's okay.
Yeah.
Now, some people say some of them might look like a V instead of a U. Okay, here's the thing. We could form a V with probably a lot of these if we want. But because we know they're quadratics, we know their function is graphed as a parabola. It has to be a smooth U. So if you get situations where it's a really, narrow U, and you almost want to do a V, don't do that. Just really fight the urge to make a V and make it curve down there at the bottom. Like this. Make it curve. Make it curve. Make it curve. And even if the points are really close together. So this one here, I would try to make that a little more of a curve than make it look like a V. But most of the time, you guys, doing what we're doing here isn't going to be what you're asked to do. We're showing you this here so we can learn a lot about these functions. Okay?
What is it, Rowan?
Alright, so let's continue here, see if we can look at some more.
Fuck yeah.
Wait, my step.
Bad Rowan.
Wait, my step. Which we can do.
Alright, so the vertex is the key, right?
Let's do this.
I think when you guys graphed them on Friday or Thursday, whenever it started, some of you had trouble with finding the correct vertex. Some of them were easier than others. I gave you guys the points 2, 1, 0, -1, -2 to use, which works for some of them, but not all of them, right? And some of you had a hard time finding the vertex, so we're going to work on how to do that. Because once you find the vertex, once you have the vertex, you kind of have your domain and range then. You have your max and min. You have your line of symmetry, right? You know if it opens up or down based on what?
The U.
But before you graph it, how do you know when you look at these equations?
Wait, what?
Very good. If you take a look here, this has a negative x squared, it opens down. This one was a positive x squared, wherever they put it, it opens up. Here,
He's showing my inner beauty.
here it's positive x squared, it opens up. Positive x squared opens up.
But that's not what your mom said to me.
Positive x squared opens up. What'd you guys have? Another positive x squared? Opens up.
Problems. Yes.
Okay. Quan, yours opens down, right? What's the equation? What was the equation?
Yeah.
I think it was negative x squared plus 2x minus 8.
Okay. So the Quan opens down because of this negative. So one thing that we all need to understand is by looking at the function, you should know if it opens up or down, which then tells you if it has a max and minimum, and helps you with your range, okay? So keep that in mind. The vertex is critical, so you know where that axis of symmetry goes through, and whether it opens up or down comes from the positive or negative x squared and the function, just the x squared part. Okay? Let's see, what else did we recognize here? If we look at our list, what shape are they all used? Is there a line of symmetry? How do we find the line of symmetry again? It's right down the middle, and it's x equals. So for line of symmetry, LOS is how we just abbreviate it. It is always
Give you the D.
x equals something. And the something is where the x coordinate of your vertex is. Right? So for this one, it was 1. x equals 1 is the LOS. This LOS is right here. X equals 1, they put it in there for you. Here, the LOS is right here. They put X equals, right here, negative 2.5. Okay? The LOS here, I'm not sure what's going on here. It looks like it's right here. X equals negative 1, this dashed line through here. I think it is symmetrical down here. It gets a little nuts up there. Here, the vertex is 1.5, 7. So the line of symmetry is x equals 1.5. There's your LOS.
X equals 21.
Okay. So finding the vertex, critical, because it also gives you the line of symmetry and then it gives you the range. The x coordinate gives you the line of symmetry. The y coordinate of 7 gives you the range. The y coordinate of negative 16 or whatever would be your range. Here, the y coordinate is negative 5.5 or something. Here it's negative 9, so the range, because it's a minimum, they listed it here, it's hard to see.
You're a disgrace.
That's the range.
You're a disgrace.
The vertex, the name is all real numbers.
No, I'm gonna lose.
1 is the line of symmetry, and the vertex is 1, negative 9. See how these numbers come into play? It's nice if you can remember that. It simplifies all this.
I lose.
Okay? Is it increasing or decreasing? The next question on your list. What do you notice about these U shapes?
Stop, dude! You just put your pencil on my screen, dickhead. Would have made a die. I would have punched you.
A linear function. Is this increasing or decreasing? Increase. Going up and to the right. How about this one?
Like dickhead central here.
Now when you look at a
Yeah.
parabola,
You know what'd be funny?
Pretty much.
let's say I
If
draw
Jared
a parabola
listened
like
to
this.
Gangsta Rap. It'd be funny as hell.
From this part of the parabola,
And then,
on your
like,
left to
you
right, it's
listen to
decreasing.
classical.
But on this part, on this side of the vertex, it starts to increase. So, the generalization,
And then,
the
like,
general
Joseph
thing you need to
listened
understand
to
about
All-Star.
parabolas is part of an increase, part of a decrease.
I mean, you're rock sharpener. Thank you.
This one, on this side of the vertex is decreasing, but on this side of the vertex it's increasing. The ones that open down, on this side of the vertex, it's increasing, and on this side it's decreasing. So keep that in mind, unlike linear functions where they're either increasing or decreasing, quadratics are a little both. Parts are increasing, parts decreasing. Are there any asymptotes? I talked a little bit the other day about what an asymptote is. You guys, these don't have it. Quadratics have no asymptotes, neither do linears, but there are exponential functions
Yeah.
in math.
No.
If you guys have ever seen a graph that looks like this,
It is
it
diarrhea.
has a dashed line.
It's crippling depression.
Like those.
Shut up.
Vertical lines that are dashed like that, not a line of symmetry like we're talking about, but those types where the function never hits it, it just runs along it and as close to it as possible, that's what an asymptote is. So it'd be like x equals 4, x equals 8, whatever those are. But for quadratics, you need to understand they don't have it. Okay? Because the domain is all real numbers. If you go left and right forever, it can cross anything. Okay?
Got him.
So anyway, that's just something for
Got him.
others to relate to other functions. We don't have any asymptotes. Are there any x-intercepts? Well, it depends. Does it cross the x-axis? Sure. Those are the x-intercepts. Does this one have x-intercepts even though they don't show it crossing the x-axis?
I'm here for
Right.
a second.
Those continue forever, so yeah, I got two x.
In my
Two x-intercepts.
I know what you don't want to do.
Two x-intercepts.
It.
This one, two
No,
x-intercepts.
I'm gonna
This one, two x-intercepts. They don't all have two. Because this one here.
Seriously, I want to see what
I'm doing something at the moment.
This one here.
It's almost over.
You're not in a battle.
Their vertex is on
I need to
the
collect this.
x-axis.
But you're not doing anything.
So how many
Yeah.
x-intercepts does this function at? Just one. It's wherever that x, the vertex is. Where this one has two. It's wherever it crosses. And then there's another one around here somewhere. Decline, what's yours look like? Does yours cross the x-axis? Or is it below it?
It goes below it.
It starts below it?
Yep.
Okay.
Oh, no, wait, it does go below it.
Okay, well, it might be one that we didn't get here,
It's
but.
like 1.7.
Okay.
Well, alright, guys, that's it
Here's
for
the
today.
idea. Look at mine right here, this parabola I grabbed.